Welcome. Hi, this is Thomas O'Neill, your host for the Voynich Manuscript. And we're looking at an elusive word over the decades. Well, since the turn of the century, the 20th century, or perhaps 100 years from now, and then on, many hackers, people who wanted to decrypt this manuscript, have sat and wondered at it. Otol, the Eva Voynich word for it anyway. And they sat and they looked at this word right here, because it just happens that it is right here in the vegetable section for a leaf, and it is in the the star section right here. There's O'Toole. So there it is 3 times. So why would Wilfred Voynich place this 3 times? And this would be a label for fire, obviously. And this is for ether or air. And I've wondered. And then I just came up with the idea. Well, not the idea. In my cipher, there is the solution. And it's another puzzle. Wilfred was a man of puzzles. Yes, he was, as I take a drink. He was a man of secrets. He was a revolutionary in the Russian, Polish Revolution. He was a man of secrets. Wilford constructed this cipher. It's not a cipher. He made the script that hid the cipher. And the cipher wasn't that much complicated. It was just Latin. Latin, yet what he did is he made a conlang, a constructed language with prefixes and suffixes, and he obscured the Voynich manuscript with very few Latin words, and he hid some meaning in the document, but he obviously didn't make every word Latin. If he did, it would have been discovered ages ago just through a run-of-the-mill scan. No. He put meaningless words and mixed in some words that actually make sense into the manuscript. Most of the manuscript does not make sense. He used abbreviations. The 4 numbers, quattro, octo, and novum, are throughout the whole manuscript. And they do have meaning. Novum, the number 9, actually means novum for nova. Supernova 1006. Octo is an abbreviation for his October birthday. And quattro might be something to do with the April 4th, 1006. Those are my assumptions. And they're generally backed up by what I found in the manuscript. Back to this, so a tool. This word right here, and this. So I've sat and wondered for years, what does this mean? How can it be? So if we go here, yes, in 1900, mathematicians knew about absolute certainty that the decimal representation of pi goes on forever and never repeats. The fact has been rigorously proven more than a century before the turn of the 20th century. So they knew that. They knew that pi, and you're wondering why am I, let's get back to the fact why I'm saying this is pi. If we put in O'Toole, and we will, well, I can copy that anywhere, but we'll just, to make it for your satisfaction, we'll click on this. Here's O'Toole, highlight it, I'll copy it. And once again, we will revert to my cipher, and we will put it in my cipher. and we'll decode it. In the middle of the word Otol is pi, and I got to thinking, since pi never repeats and goes on forever, the numbers are unique and they can spell words. Well, um, at the turn of the 20th century, using numbers for letters, did they theorize that any word could appear in pi? Yes, this exact theory was born right at the turn of the 20th century. In 1909, French mathematician Emily Borel introduced a revolutionary mathematical concept known as normal numbers. A number is considered normal if its digits are completely random in a statistical sense. This means every digit and every possible combination of digits of any length will show up with exactly equal frequency over time. Because words can be converted into numbers, for example, assigning A to 1, B to 2, C to 3, or using binary text code, the theory of normal numbers directly implies that if pi is normal, then every word, book, and digital file I've written must appear somewhere within its digits. Now, before I even looked at this, I decided to run this in Claude. I checked the first 50 million digits. Well, I didn't have to go that high to find it because igneous, because I'm using Latin, because I probably could have very well just used fire, but since it is a Latin cipher, I used igneous. And igneous means fire in Latin, as you can see right here. Um, so back to the Claude, at the 12,964,000th roundabout uh, million number, the string of numbers 9714919, which if you use 9 for I, 7 for G, 14 for N, 9 for I, and 19 for S, those numbers would refer to igneous. So, igneous is found in the Voynich Manuscript. So Wilford was using pi because he figured if he researched, and Wilfrid Voynich was a bookworm, he researched everything for this manuscript. And the word was found in the word was found in the string of digits string of digits string of digits of pi. So the string of digits of pi. I'm getting some background noise. I'm sorry for that. Um, so if we go over here to this star system and this plant, you could put in basil, or you could for any four-letter star for the star. You can find the star in pi. So, oh, there's. It doesn't have to be four letters either. It's just referring to pi. And I wonder if he intentionally wrote it with four letters and said pi and said it had to be four letters. Let's see if we can search for phi. No, since it's in Latin. Um, oh, that's an interesting thought. No, I don't think he went that far. I think he's just dealing with meaning. And the puzzle was that if you researched and found the word as in a number, that you referenced it to fire, that you could use pi to find. He's using pi for that. I don't think he's keeping it to a minimum of 4 letters. But we don't know what he's really doing there, do we? So I can't conclusively say that. However, I did find igneous in a string of numbers that would spell igneous for fire and, well, we could say what is fire. Well, here we go. Fire shows up 507 times, and igneous shows up 6 times. I think he meant igneous. Huh. Um, so if you were wondering about Otol, and why this, what with the label, why the label has 3 labels for 3 different pictures, I think I found a solution to the dilemma. My cipher picks up pi. Uh, it picks up pi in the middle of the word, and we have a tool represents igneous for fire. Looks like basil, and either a constellation or a star. I'm thinking it's a star, but whatever star at directly east. Um, and I happen to find out, or it could be a planet, but I found out what these uh, these moons were doing. This is actually on April 30th, 1006. So whatever star, this very well could be the Pleiades over here. 1, 2, 3, 4, 5, 6. It could be a star system in the Pleiades. Mm-hmm. Because Taurus was over here, but I'm not sure he was referencing that. There's the Pleiades right here in this image, and this is a waning crescent moon. Um, if you want to take the journey with me, I might as well have got some time. Let's take the journey and see if we can figure out what this little star is here for April 30th, 1006. Because I don't know if it has to be a 4 letter star, but we can see what star is directly appearing. Let's do it. Uh, Stellarium Web. So go to Stellarium Web. Oh, the net is a little slow today. This is weird. Um, I'll pick up this for um, Italy. We can go for northern Italy. Let's go for northern. Uh, what's a We'll go for Rome. We'll go for Rome. Rome. Uh, we could go for Rome or uh, Ferrara, Italy. Let's go Ferrara, Italy, just to make it more like what he was thinking in his manuscript. So Ferrara, Italy. Okay. So we use that location. Then we'll change the date to 1006. 1000. Okay. Bear with me a second. Let this clock down to 1006. If you just want to see if there's a, I think the waning crescent is around 1006 on April 30th. So we'll just have to go to the time to see if there's a star on the horizon. See what star is there on the horizon for the waning crescent. So we're going to 1006 on April 30th. 1006 and April 30th. We'll take this, let's close this out. Take this out and go north. Is this? Um, where's the moon? Um, there's the moon. It's a waning crescent. And there is something right here on the horizon. Altair. Hmm. We might have found out what the star was he was talking about. Altair. Altair is the brightest star in the equatorial constellation of Aquila, the 12th brightest star in the night sky. It has the Bayer designation. So Otol, I would surmise, is Altair. Look, I'm guessing that. I'm not guessing. I'm making a appropriate. There's the there's the crescent moon. Um, we should probably bring. Um, well, if the crescent moon was south, so let's bring the crescent moon about right there. Would it be Altair, or should we bring it? Or is it Mercury? Um, I don't think it was Mercury. Where's constellations? There's Taurus. So um, the Seven Sisters would be up here next to Taurus. Where's Altair? I'm gonna have to go with Altair because the moon was showing, and Seven Sisters would be right here next to Taurus. Yeah, Altair was really bright. He made it really. So Altair was right there, and here we go in the Voynich Manuscript, and for the yeah, that'd be right there. Um, it's Altair. So we figured out which star this was. Otol's. Now we could put in to see Altair. Tear. Check our spelling real quick. Altair spelled that way. Altair, can we find that? Let's try that. So we're looking for Altair. See what the string is. This is a 6-digit number, but it could be a greater. It's probably, well, they found it. That's one's actually a decent test case. 9-digit string, expected occurrence rate of 1 in 5 times in 50 million. Finding exactly once is unremarkable, right around what chance predicts, not evidence for against or anything either way. Found once. 24 million. So Altair is in the pi. So we found Altair. Anyway, thank you for watching this video. I thought, how would you get this label to work? And I looked at the word and it didn't have pi in it. And that's what led me to believe he used this. And trust me, Wilford Voynich used puzzles. And pi is no 14th or 15th century word. It's the spelling is a word from the 18th, 17th century for 3.14, or the infinite amount of digits that proceed after it. Um, Unrepeatable, um, forever they go on. And well, anyway, thanks for watching.